So on number 1, we are required to write this function x plus 5 raised to the power 4 in standard form, and that means we do the binomial expansion, and then after we are done with that, we find the y-intercept of the function. So the first thing is to look at the variable. I'm raising it to power 4, so I start with x4, x3, x2, x1, and then starting from the other side, I start at 5 raised to 4, because I have 5 here, 5 raised to power 3, 5 squared, and then I have 5. And then the next thing I need to remember are the coefficients. I make the Pascal triangle, and these are the coefficients I need to use. And then I plug the coefficients. You can see them here in red. And then the last thing I need to do is to simplify. Remember, I have to multiply those out. And the first one is just 1, but the next one is going to be 4 times 5. That's how you get 20. This is 6 times 5 squared, which is 25. You get 150. The next one is 5 cubed, which is 125 times 4. That's how you get 500. And the next one is 5 to the power 4. We get 625. And when you get 625, remember this is also going, the constant is your y-intercept. Or if you plug in 0 into this equation, that's what you get. Okay, question 2, we are supposed to write the equation of the horizontal asymptote, or explain if there is none. So the first one, I just looked at the highest degree, the highest exponent. So the top one is cubed, the bottom one is to power 4. So I see the highest degrees at the bottom, and I can simplify that. But whenever I have the highest degree at the bottom, it means I have 2 divided by a very big number. And when I'm dividing 2 by a very big number, the answer is going to approach 0. So the horizontal asymptote is just going to be y is equals to 0. Going to the next one, I look at the highest exponent. So I see 4 power 3. And this one, I'll be left with x on top as a denominator, as a numerator. And that means if I plug in a big number on top, it will just keep getting bigger. So that means the horizontal asymptote does not exist. Okay, and now the next one, I have the same highest exponent on both, same degree. Whenever the degree is the same, I just need to take the coefficients of the leading coefficient. So you can see this one here of the leading coefficient. The leading coefficient for this one, you see, is -5. So you got to remember the negative here. And this is positive 3. So positive 2. So I put 2 there. And that's going to be the equation of the horizontal asymptote. So it's about the 3 rules, comparing the degree of top and the bottom, or just looking at these simplified equations and try to plug in a very big number, and you see what the function is going to approach. Okay, the next one, number 3, we are looking for the domain, and to find the domain, we need to set the denominator to 0. Here I don't have any hole, so I just writing the domain, and even when we have a hole, just look at the denominator, make sure it's factored out, and then find any value which will make the denominator 0. So in this case, to write the domain, I just solve this one, make it equal to 0. If I plug in -4, I get 0. Anytime we divide by 0, that's undefined. Anytime I put 10 there, it's undefined. So the domain is all real numbers except -4 and except 10. So another way of writing this would be from -infinity to -4, and then union Then you go from -4 to 10, and then from 10 to infinity. That's another way of writing the same thing. And of course, for the vertical asymptote, it's just going to be in equation form. X is equals to 4. We are setting the denominator to 0. X is equals to 4 and X is equals to 10. So for this one, number 4, we need to write the equation that satisfies the criteria here. So the first one, I see they have an x-intercept. To get the x-intercept, which is the same as a 0, you need to set the numerator to 0. And why am I only setting this one? Because if I check, this one is common, this is common. I'll actually highlight that. Since it's common, when we cross it out, we are going to get a hole at that point. So going back here, so this is the only one which is going to be left. So I make it equal to 0 and solve, and that's how I get the x-intercept. For the vertical asymptote, I need to look at the denominator, and whatever denominator is left, I make it equal to 0 and solve, and that's how I would get x -2. Remember, since the degrees are the same, this is squared, then this coefficient here is what gives you the horizontal asymptote. And then if you look at the common factor here, x plus 3, if I solve it, that's what's going to give me the whole. So this is one of the equations which satisfies this example, the criteria given. Okay, for number 5, here I have a table, and what I need to check here is this notation here means I'm approaching 8 from the left hand side. So if I approach from the left, so what is happening from the left? As I come from this direction to approach -8, I want you to notice that these numbers are getting smaller and smaller. So what is happening to h of x is it's actually going down. It's going down. The values of h are decreasing. The values of h are decreasing. So the graph would go like that, going down. If I approach, this one here means approaching -8 from the left, from this direction. What's happening to h of x? See the values here from 191, 1991, 19,000. So the values are getting bigger and bigger. So what's happening is that the values are increasing. And what you can see here, there is a line which is being approached here but not touched. Anytime you see the values increasing on one side, decreasing on one side, increasing, or it could be the opposite, then that means we have a vertical asymptote at that point. For the next example, for number 6, so here we are given an equation. So the first thing you want to do is to factor out. So you factor it out, the numerator and denominator. So I factored it out here. And then the first thing I did was to check whether there is a hole so that I can simplify. So I canceled this one. So I know there is a hole at x is equals to -5. And then when I simplify, this is what I'm left with. Then I can proceed. To get the x-intercept, I need to set the numerator, whatever was left, to 0 and solve it. So the x-intercept, or the 0, is x is equals to 2. Now, to do the vertical asymptote, I need to check the denominator. So whatever was left, x minus 8, I make it equal to 0 and solve. Then, to find the y-intercept, what do? I need to look at the simplified equation, or I could even use the original here and plug in 0, set x to 0, and then so for y, and that's how I get 1 over 4. You could still use the original equation, you get the same thing. And then to find the ordered pair of any wholes, so you know the whole is that x is equals to 5. Remember the factor we cancel down. Then I need to plug that into the simplified form of the equation. This equation right here, this expression here. So I plug in -5 right there, and -5, and when I simplify, that's how I get 7 over 13, which gives me these coordinates. And then for E, to find the horizontal asymptote, I compare the degree. I see the degree of top is the same as the degree of bottom, so that means the horizontal asymptote is going to be y is equals to 1. Okay, for the next one here, I'm given x equal to -1 is an x-intercept, which is the same as 0. Write the function in fully factored form. So I look at my equation. Since I cannot factor it, I'm going to reduce it by dividing by -1. I will use synthetic division. So when I do that, this is what I get. These are my coefficients. So I get these coefficients, which translates to this equation. Then I factor this equation. I get these two factors. And these are the two factors right here, plus the original one, x plus 1. This one comes from x minus 1. So that's the fully factored form. Okay, we go to number 8. Here we are given an equation, and we are given a graph, and we are told to find all the zeros of g of x. So this should be find all the zeros of g of x. Find all the zeros. I already know I have 3, so I'm going to use 3. I use my coefficients. The simplest method is synthetic division here. When I do that, I'm left with 1 and 4. When I write that as an equation here, I get x squared plus 4. That's the other factor. I use it, I make it equal to 0 and solve it. I make it equal to 0, so I make it equal to 0 so that I can solve for x. So I get x squared is equal to -4. X is equal to square root of plus or minus square root of -4. So I get plus or minus 2i. And this makes sense because I expected to see 3 zeros, but I only see 2, one of them. That means 2 are imaginary, because imaginary come in pairs. Then the final thing, and I only have 1 a of 0. This is 1 a of 0. So now I write the function. So x minus 3 using this intercept, and then x minus 2i, x plus 2i. Okay, the next one, I'm told find the quotient of, given this equation, divide by that. So how do I do that? Synthetic division. So I'm going to divide, put -4. Always remember this is the opposite. And these are my coefficients. I use them to write the equation. Go 1 degree down, that's how I get 3x squared minus 7x plus 12. This is my remainder. So for number 10, we are told find the slant asymptote of this equation. This is a function, rational function. So the first thing I need to check is the degree. The degree of the top is 1 more than the bottom. That means I have a slant asymptote. And I cannot use synthetic division for this one, so I use long division. So I set it up, and then I look for, I wanted to make sure I get x cubed here. So that's why I multiply by x, everything by x. So that's how I got x cubed, 7x squared plus x. I subtracted. This is 0. 2 minus -7, that gives me 9. -4 minus x, get negative 5x. I need to bring the 8 down because I need 3 terms. Then I multiply it by 9 so that I could make this equal. Then I subtracted. When I multiply everything by 9, I get 9x squared, negative 63 plus 9. I subtract. And this is negative 5 minus negative 63 gives me positive 58. 8 minus 9 gives me negative 1. So this is what I get, x plus 9. This is my remainder. But if you think about this remainder, for large values of x, because the dominating term is in the numerator, this will become very close to 0. So that means this function is going to behave like this line. So this is the horizontal, this is the vertical slant asymptote, x equal to 9. I wrote it as an equation of a line. Okay, now number 11. So we are given this function, determine the equation of the vertical asymptotes. Okay, so the first thing I always do is to find if there is a hole. So I see there is a hole at x is equal to minus 1, so that I get rid of that. So to get the asymptotes, I look at whatever is left in the denominator. So I see I have a 3 and a negative 3. So that means I make each equal to 0 and solve. So I have negative 3 and positive 3. They should be positive 3. So those are the intercepts. These are the intercepts. The next one is asking me for real zeros. How do I get real zeros? Whatever is left in the numerator, make it equal to 0 and solve. And that's how you get negative 2 and 4. The next one is asking for horizontal or slant asymptote. And I just need to compare the degree. 1, 2, 3. Top is 3, bottom is 3. Because the degree is the same, the coefficients are going to give me the horizontal asymptotes. And here, I know I have 1, and I have 5 at the bottom. So that's how we get 1 over 5. For this, for number 12, we are given this equation, and there is a constant c. So we are told find the value of c, so that x plus 2 is a factor. Because I know x plus 2 is a factor, I expect to get a remainder of 0. Okay, so I write my coefficients, but look at the 0 in red. If you look at this equation, I don't have x to power 4. It's 5, 3, 2, 1. Because I don't have that, I need to put a placeholder 0x to power 4. That's why you have 0 here. That's where the numbers are going to line up. Then I do synthetic division. So the trick here, just make sure you put that 0 because it's missing. And then when I do it, here this is still c, again negative 24. So I know this number here has to be 24. So that's when I subtract, I get 0, because I know this is guaranteed to be 0.